So we're going to use square roots, and those will help us cancel out the exponent of 2. I'm sorry about the little error there. And then cube roots cancel out the exponent of 3, or the cubed exponent. So as we take a look at this whiteboard now, how am I going to get rid of the squared that's attached to x? I just want this to say what x is equal to rather than x squared. I perform a square root on both sides. I don't have to write the little 2 as the index. Anytime I see a radical without a number, I know we mean square root. The square root of x squared is x. Those two things cancel each other out, and we should know that the square root of 36 could be 6. And here it also could be a negative 6. That's why I'm putting a plus and a minus. Negative 6 times negative 6 makes positive 36. And one thing we should remember is these equations that say x squared equals a positive number have two solutions, positive and negative, because a negative number squared also makes a positive. You should see similarly for y squared equals 50, what operation needs to be performed? We need a square root to get down to just y. And if I square root on the left side, I have to square root on the right side. The square root of 50, positive or negative version of it, is my answer for y here. Now if I take a look at my calculator, square root of 50, I can see that as also something I could rewrite as 7.071, and it keeps going. I could just probably round that off to 7.07. Just a little bit above the square root of 49, which would have given us 7. For the final one, how do we solve the equations that have a cubed in them? We need to take a cube root, or perform the inverse operation of cubed, which is the cube root, to both sides. That says what number to the third power would be given us 20. So the cube root cancels out the cubed with m, and then I need to be able to take the third root of 20. I know that 2 cubed is 8, 3 cubed is 27, so the cubic root of 20 is my answer. It's not going to be a whole number, it's going to be 2 point something. I could guess 2.5. At the end of the day, we could use a calculator to get the exact cubic root of 20, but it's going to be something between 2 and 3 because the cube root of 8 is 2 and the cube root of 27 is 3. So if I had to estimate, I'd say around 2.5. Going to go ahead and back out of the whiteboard now. We're going to take a look at the next part, part 3 and part 4. Part 3 says write an equation that could be used to find the side length of this cube below. We're given the volume of a blue cube. It's 125 cubic feet. So your job is to come up with an equation and then solve that equation to find the side length. Go ahead, pause the video. I'm going to replace this whiteboard. As you're coming back after pausing the video and trying to solve part 3 and part 4 on your own, the equation you should have gotten, if x is the side length of this cube, x cubed should equal 125 because the volume of a cube is side length cubed, whatever the side length is, s, to the third power always gives us the volume. Remember, length times width times height, and for a cube, the length and the width are all the same side lengths. That would be part 3. For part 4, how do we solve that? Hopefully you understand now the way we solve any cubic problem. The way we get rid of the third exponent is to take the third root from both sides. And the cubic root of 125 is 5 because 5 times 5 times 5, or 5 to the third power, makes 125. That was a little rushed. Please feel free to grab me or Miss Stewart if you got some questions on the last parts here.